Hello friends, welcome back to OK Java. In this video, we'll talk about one of the very important Java 8 interview questions. And so we'll see what is Java 8 stream or alright. So here in this video, we'll see what are different characteristics or the properties of Java 8 stream. You can use these points to fully answer this particular question. Alright, so that being said, let's begin the video. So what is a stream? So in very basic words, a stream is like flow of water, which is a water stream. Correct. Similarly, in Java, we have data stream. So flow of data or sequence of data elements. It becomes a stream for us, right? So you have a source of data or collection of data or huge amount of data. You convert the data into a stream. So it continuously keep on flowing, similar to the water stream, right? So stream is flow of data or sequence of data elements. That's it. Simple. Now, Java Stream API provides handy functions to work with the collection. So I will be explaining this particular point as part of the examples because this is our very first video on Java 8 Stream API. I will be coming up with the more videos and we'll talk about, I will keep on explaining this particular point in all the videos, in all the coming videos on Java 8 Stream API. But the point is, if you are working with the collection, right? So Java 8 Stream API provides so many useful functions and that it like those functions will make your life easy. You just need to write very small piece of code to get your expected results. All right, so let's move. Now here, let's first understand the stream pipeline flow because it's one of the very important question and as a developer you must know how it works internally. So first of all you will have something called a source. So source, it could be collections like for example list or map or set, or it could be an array as well, or you can pass the data as an input to your program, to your stream, or you can read the data from a file, right? So first of all, you're going to have a source of data and then you will convert that source of data into a stream because stream API, it works on a stream. You cannot directly work on your original source of data. You need to convert that source of data into a stream. Once you have your stream ready, you can apply operations. You can apply either intermediate operation or you can apply terminal operations. So as you can see here that we have two categories of operations. One is non-terminal operation and then one is terminal operation. So as you can see here, we can apply multiple intermediate operations. Why? Because you can make use of these intermediate operations to apply your business logic, and in the end you use a terminal operation which will give you a final result. So final result could be anything. For example, you are passing an integer list and you want to find out the max even number, right? So you can apply your business logic here as part of intermediate operations, and then you can apply your terminal operations to get your final result. So terminal operation will give you your expected or the final outcome of all your operations, right? Or even you can use terminal operations. For example, you have an integer list and you want to fetch uh, a list of having even numbers only, right? So you can apply your business logic here, and then by using terminal operation you can collect the data as a list of even numbers. All right, so I hope I'm making some sense here. So how your stream pipeline works is that you will have your source of data and then you convert your source of data into a stream. Now there are multiple ways to create a stream out of a source, so that I'll cover in the next video. But you need to understand that you have source of data. You will convert your source of data into a stream. Once you have your stream, you can apply multiple intermediate operations to your stream, and in the end you can apply only one terminal operation. All right, so let me give you an example here. I think if I'll show you some code, it will make more sense. So let me open the IDE. All right, so here I'll create a program. Let me create a class. So I'll call it a Java 8 stream void man. Okay, so here we are talking about stream pipeline flow, right? So what is very first thing? First thing is that first of all you need to have a source of data. You need to have a source of data. So I will take a very simple example. I'm taking a stream. I'm taking a list of integers. So I'll call it as int list, right? And then I'll create a list by using very simple function as list 1 2 3 4 5 6. I think enough for now. Let's import java.util.package. Cool, right? So I have my source of data, right? Data source is there. Now I need to convert, because if you want to work with Java 8 Stream API, the very first thing is that you need to create or convert your source into a Java 8 stream. That is the very first thing. You cannot apply all these stream operations on a collection. First of all, you need to create a stream out of it, right? So what I will do, I'll go ahead and use a function called stream. So I've used my list.stream is the function that will create a stream. Now there are multiple ways to create a stream, but we are using the very basic one, dot stream function, right, to create a stream. Now if you look at the output, the return type, this particular function, it will give me what? It will give me a stream of integers, right? So what I will do, let me just store the stream. Okay, 1 second, sorry. Stream of integers, and I'll call it as int stream because it's my integer stream. Simple. Let's import in stream. Java.util.stream is the. Okay, so now second task is achieved. Now we have our stream. Correct? Next step is to apply some intermediate or non-terminal operations you can apply. Once you have your stream, you can apply non-terminal or intermediate operations. For example, I'll take my int stream. What I want to do is I want to filter, like very simple thing. I want to filter. Can you please give me all the numbers greater than 3? That is my requirement, right? So I'll use a filter. Now if you look at it here, filter is asking to pass me a predicate here. So what is the predicate? What is the predicate? Predicate is a predefined functional interface, right? So it takes some argument. So basically we use predicate to apply some conditions, and it will always return either true or false, right? So what I'm doing here is I will pass my element here, the elements which are greater than 3. Very simple thing, right? If you look at it at a filter function, this is also giving me a stream as the result. So what I will do, I will also store this into another stream. Okay, so I'll create a stream of integers, and this time let me call it as filtered stream. Why? Because now I have applied a filter operation. Just for simplicity, I'm calling it as filtered stream. Now, as I told you, you can apply multiple intermediate operations. So filter is one of the intermediate operation in Java 8 stream, but there are a couple more. Let's go ahead and apply one more intermediate operation, right? So what I will do, I'll take this filtered stream here, and now what I want to do is I'll apply a map. Map is again one of the non-terminal or intermediate operation, right? So if you look at it here, this map function is asking me to pass a function. What is a function? Function is again a predefined functional interface. So you can use function to apply some operation or to convert one object into another one. That is what the purpose of function. If you guys are very new, you can watch my video in which I have already explained how function interface works, right? So what I will do here, I will let my logic. What I want to do is take the element and multiply the element or the number by itself. That is what is my intention, right? So if you look at it here, map will give you a stream of integers. So let me just go ahead and store the result. What I will do, I'll get another stream, and this time I'll call it as computed stream, because here I have applied my business logic. In happy. So far what we have done, we have created a source of data, which is my integer list. Then we have created our integer list into a stream, and then we have applied two intermediate operations. One is filter and second one is map. Simple, right? Now I'm going to apply a terminal operation. So as I told you earlier, terminal operation is the operation or the functions that will give you the final outcome or final result, right? So for now, I will just print the result. I want to just make sure that whether my logic or my things are working as expected. So what I will do, I will simply print the filtered stream. So what I'm using is I'm using a for each function. And if you look at the input, for each function is looking for a consumer. Now, what is a consumer? Consumer is one of the predefined functional interface. Consumer, it takes an argument and it does not return anything. So basically, in very simple word, it consumes. So whatever you will pass, it will simply consume. So what I'm gonna do here is I have my, you can say A is like my is my result set, and I simply want to print here system.out.println, and I'll use A. Simple, right? What I'm doing here is I'm iterating through the filtered stream and I'm printing the result set here. Simple. Now let me run the, oh sorry, I have to apply this on computed stream, not on the filtered one. Right? So let's run this one. So you see your result is 16, 25, 36. What is happening here is in our input list or source list, there were 6 elements. Then we applied a filter. Okay, give me the numbers which are greater than 3. So I have got 3 numbers, 4, 5, 6. And then I have used another intermediate operation to multiply the number by itself. So 4 multiplied by itself is become 16, then 5 into 5, 25, and then 6 into 6, 36. Correct? And finally, we applied a terminal operation to print the values, the output. Correct? So this is how your stream API or the stream pipeline works. You will have your source of data, you will convert the source of data into a stream, and then you will apply multiple or a single intermediate operation, and then finally you will apply your terminal operations. Clear? Let's move. I hope you guys are clear with the stream pipeline flow, how it works. Let's proceed. Okay, so here we'll talk about some of the very critical or very important feature or properties of Java stream. Right, so the very first one is stream does not store data, it operates on the source data structure. What it says, stream does not store the data. Let's go back to the ID. Okay, so if you look at it here, right, we have used list, integer list to store our data. We are not using stream to hold the data. We are using a collection, right? Because list is a collection, right? It's part of collection family. So we are using collection. It stores the data, but integer but stream does not store the data. What it does, it basically, if you see here, right? Here we have created our stream, integer stream. Oh, it's a stream actually. There is a spelling mistake, right? So what I'm doing here is we are passing this stream to a function. So initially, like this is our first stream. We have supplied this stream. We have passed to the operation filter function. Then the result of this filter is again a stream, which is filter stream. Then we have used this filtered stream to pass as input to the map function. And the result of map is again a stream which we have used to pass as input to the for each function. So what is happening here is that we are not storing data in a stream or into the stream. We are using stream as a pipeline to supply the data to the function, to the calling function. So basically we have used int stream to pass data to the filter function. Then we have used filtered stream to pass data to the map function. Similarly, we have used computed stream to pass data to the for each, right? So your collection, right? Your collection, I'm saying like list, set or map. We use collection to store the data. Then you can do whatever you want to do. But a stream API or a Java stream does not hold the data. It does not contain the data. It simply provides a pipeline so that you can pass the data to the calling function. Clear? Let's move. Second point, operations performed on a stream does not modify its source. One of the, you can say, a good feature of Java stream that it does not modify your source. Let me just explain. So if you see here, int list or like integer list is my source. Let me print this one here. So what I will do, source, and I'll call it as pre. Then pre in the sense like before applying any operation to it. And I will print our source list here as well. Let me just call it as post, right? Here we have converted our integer list into a stream, and then we applied all our business logic and we have got the output. And here finally I'm printing the same source list. Let's see how it looks like, or what is the difference between these two. So here is your your source list before doing any operations. Here you have applied all your business logic. You converted your stream into your input integer list into a stream. You applied all your business logic and then you got your result. And here is your post list after applying everything. So your source is intact. So Java stream does not modify your source, right? Your collection or whatever it is. So stream is not going to modify the source dataset. Clear? Next, elements of a stream are only visited once during the life of a stream. So this is one of the very important point that you need to keep in mind, that you cannot operate or you cannot apply multiple functions on a same stream. You can use your stream just only once. You can apply only one operation to a stream. Let me explain how. So here is my int stream and we have applied a filter. Can I just apply one more filter to it? What I want to do is int stream dot filter, and I want to, can you please give me the number less than 5? Simple. Here I'm fetching like I've used filter to filter out the input list input list. Give me all the elements greater than 3, and what I'm doing here is give me all the elements less than 5. Simple thing, right? So basically I have applied another operation, another stream operation on my input stream, on the same stream. Let's see the result, how it behaves. You are getting an exception, illegal state exception. Why? Because your stream has already been operated. What it says, your stream has already been operated, because it means that you have already applied some function onto it. You cannot reuse your stream. This is what does mean, because I have already used int stream to apply a filter, so I cannot reuse, right? Now let me take this out. Let's go to the filtered stream, right? Let me just print. Can I simply print this filtered stream by using the same operation? So what I will do, I want to print, right? So I will use for each. Correct. So this time I'm using method reference to print the data, the elements of filtered stream. It's one of the handy way. Or I want to print my filtered operation. I've already applied one function, and then I've applied another method called for each. Let's see the result. What do you see now? Exception. It says that the stream has already been operated at line number 25 here. Okay, so the point is that you can use your stream only once. You cannot reuse the same stream, right? So basically you can apply only one function, one terminal or non-terminal operations to your stream. Simple. Okay, next point. Next is non-terminal or intermediate operations generates another stream. One of the good point. Okay, here. So here we have applied a filter to our input stream. Correct? Filter. If you see, the result of filter is another stream. Filter is the intermediate operation, and this is giving me another stream as a result. Similarly, map is one of the non-terminal operation, and it is giving me, if you see the return type, it is generating a stream. So this is giving me another stream, right? So intermediate operations or non-terminal operations will generate another stream to operate. It will give you another stream as a result. But terminal operations will give you the final result. If you see for each is a terminal operation, it will give you the final result. If you look at the return, it's a void. But it is not that you will always have a void. You can get another list as a result, or you can get a number, whatever. But the point is, terminal operations will give you final result, and the non-terminal operations will generate another stream after applying the operation. So here is my int stream. We have applied a filter. We have got filtered stream. we have applied a map, we have got computed stream, right? What is next? Next is stream operations use functional interfaces. So it's easy to use Lambda expression. Okay, so if you look at it here, right, I don't think that I have to explain what is functional interface or what are the predefined functional interface. If you guys are new, you can watch my videos. I have already covered all about functional interfaces and all about predefined or inbuilt functional interfaces, right? So if you look at it here, filter is a function, right? If you see the result, the input parameter, filter is expecting a predicate. Predicate is a predefined or inbuilt functional interface. Map is again taking one function interface. So function is a predefined functional interface. Similarly, for each, it is taking consumer. Consumer is predefined functional interface. So if you are dealing with functional interface, you can use Lambda expression to write your business logic. For example, if you see here, this is one of the Lambda expression to filter out the elements. This is one of the Lambda expression to multiply the number by itself, correct? So most of the functions of a Stream API are using functional interfaces, so it's easy. So you can. Next point is that Stream support sequential as well as parallel processing. Okay, so we'll talk about parallel stream in the coming videos. But the point is similar to the stream, like the way you have created a stream function, there is one more function called parallel stream. Parallel stream. So basically what it does, when you are working with a huge set of data, large collection of data, you can use parallel stream. So this particular function will split your input stream and it will generate multiple or you can say sub streams, so that you can apply your business logic parallelly. So similar to the multi-threading concept where you have multiple threads operating on same set of data, right? Applying same kind of business logic, you can use parallel stream. So parallel stream will split your data set into multiple streams and you can apply your business logic. So this gives you a fast processing, or you can say a high performance. So we'll talk about parallel stream more in the coming videos. But yes, similar to the stream, we have parallel stream, right? All right, so here you have seen that we have wrote so much big code to perform our operation, but this can be done in one line as well. So what I will do, I'll show you how. One liner code. So first I will take our input list, which is an integer list. I will convert this list into a stream. And then now let's go and apply a filter. So filter is similar thing. I can reuse the same logic. That can you please give me the elements which are greater than 3, and then I will use a map here. Map to multiply the number by itself, like the elements of a stream to multiply by itself, and then I'll use a for each function. So for each system.out : println. I believe you guys still remember this double colon operator. This is known as what? Method reference. Now let me run this one. What do you see? Same result in just one line of code. So this is the beauty of Java 8 stream and Lambda expression, that you can do complex things in a very easy manner. You don't have to write much logic, right? So what is happening here? Convert your collection into a stream, your source into a stream. Once I have my stream here, I have applied a filter because I know that this particular function will give me what? Will give me a stream as a result. You see here? Then I have used filter. I have applied filter on my stream. So filter function, I know that the result of filter is going to be another stream. So my map function will apply it on the filtered stream. My map function here, it will multiply each element of the filtered list by itself and it will generate another stream. If you see the return type of map function, it is stream of integer, right? And then from here I have applied a for each. If you see the result, the return type of for each is a void. It will not return anything. It will simply consume, because for each function is expecting a consumer. If you see here, it is taking a consumer. What is a consumer? Consumer is consume. It just takes the parameter and it simply consumes. It does not return anything, right? So the point is, by using this one liner of code, you can write a concise code. All right. All right, guys. So here we are done with this video. In this video, we have covered what is the Java stream. We have seen the stream pipeline flow, and yeah, we have covered the few non-terminal and a terminal operation as well. But we'll talk about more in the coming videos. Thank you for watching, and please subscribe my channel.